Hi, and welcome to day 7 of logs. This is modeling with exponential and logarithmic functions. So writing exponential functions, did you know that 2 points determine a line? So you shouldn't say do you know that 2 points determine a line. Did you know that it's also true for an exponential function? We've always been able to find the equation of a line given 2 points. Well, we can find the equation of an exponential function the same way. So we have 2 points, the point 1, 6. Oh, that's not right. All right, so we have the point 1, 6 and the point 354. An exponential equation is in the form of y equals ab to the x. This is x, this is y. Same thing here, this is x, this is y. I can write 2 different equations with 2 unknowns. So my first equation, I'm going to substitute 6 in for y. A, b, x is 1. And then for the second equation, it'll be 54 equals a, b, and then x is 3. So now I need to make a substitution into the equation, so I need to solve for a here. So just divide by b. So a is equal to 6 over b. So now I'm going to take that 6 and substitute it in for a into my other equation. So I'll have 54 equals 6 over b times b cubed. So that means this b and this b are going to cancel out, and I'm going to be left with b squared. So 54 equals b squared by 6b squared. I got my 6 there. Now divide by 6. So 9 is equal to b squared, square root. So b is equal to 3. We don't use the negative because the base is not going to be negative. So now I need to find a, and in order to find a, I'm just going to substitute in. So 6 equals a times 3 to the first, which is just 3, so divide by 3. And 2 is equal to a. So my equation then is y equals 2 times 3. Oh, not to the b. That should be to the x. So let me write that over again. So it's y equals 2 times 3 to the x. And that is our exponential equation. All right, moving on. A store sells trampolines. Let's see that there. The table shows the number y of trampolines sold during the x year that the store had been open. Write a function that models the data. All right, so I have a scatter plot of all the points there. And I'm just going to pick 2 points on my line. It doesn't really matter which 2 points it is, but we'll take that one because that makes it easy. And we can take maybe this one here, spread it out a little bit so that we're making sure we're doing okay. So we're going to do exactly what we did last time. So y equals ab to the x. So using the point 112, I will have 12 equals ab to the first. And the other equation would be 36 equals ab to the fourth. So solve for a, just divide by b. So 12 over b is equal to a. Make that substitution over here. So 36 is equal to 12 over b times b to the fourth. This b cancels with this, and this becomes b cubed. So it's 36 equals 12b cubed. Divide by 12. So that'd be 3 equals b cubed. And we'll have to take cube root of that. So b is equal to the cube root of 3, which is approximately 1.44. And then we need to find a. And in order to find a, I'm actually going to use the cube root of 3 instead of a decimal approximation. So I'm going to say 12 equals a times, and b was the cube root of 3 to the first. So really we're just dividing by the cube root of 3. That will cancel out. So a is equal to, in the calculator when you approximate, 8.32. So my actual equation would be y equals 8.32 times b, which is 1.44 to the x. All right. So that should be good. Okay, so looking at this data here, we're going to use these values for the next problem. What I'm going to do is use my calculator to give me a regression model. And when I do that, it says use the graphing calculator to find an exponential model for the data in example 2. Then use this model and the model in example 2 to predict the number of trampolines sold in the 8th year. Compare your predictions. So when I do that, if you have a graphing calculator, you want to hit Stat button. And after you hit the Stat button, you want to do number 1, which is Edit. And after you do that, in L1, which is list 1, you want to type the X values. And in L2, you want to type the Y values. You have to have the same number of X values and Y values in the actual list or you're going to have problems. And then you're going to go to Stat. Once you get your data in, you do Stat. And this time you're going to arrow over to the Calc menu, Calculate, and you're going to arrow down till you get to number 0, which is EXPREG, which is exponential regression. So the calculator is going to do this for us. And once you hit that button, your X list should be L1, your Y list should be L2, and the frequency list should be nothing, empty. You don't want anything there. And the store regs, we don't need anything there, which is storing the regression line. So we're not going to use that for this part. And then you'll see a calculate button. This is the one that you want to arrow down and hit. And then when you do that, you get a window that looks like EXPREG. You'll get all these funny values. You'll get Y equals A asterisk B to the X. Actually, I think it's just caret X. And then you'll get a value for A and a value for B. You get 8.45. 737 7971. And for B, you'll get 1.4188, 1.4188, and then 48603. So that's what you'll get. Now you're going to write an equation, and typically we round everything to the nearest hundredths for these. So my equation would be y equals 8.46, and then b is 1.42 to the x. Now we're going to use this equation here and the equation that we got in the number 2 to predict the 8th year. So we're just going to substitute 8 in for x. So if I have y equals 8.46 times 1.42 to the 8th, and I do that on my calculator, I get approximately 140. Now I need to use my equation from exercise number 2. That was y equals 8.41 times 1.44, oh sorry, 8.32, excuse me, this should be 32. Y equals 8.32 times 1.44 to the x, so we're going to put 8 in for x. And when you put this one in the calculator, you get 154. They're close, but they're not that close. Your regression model is going to give you a little bit better predictor than your actual data points will give you, because the regression line is taking everything into consideration in between those points, where your data points are just basically, it's like finding the average rate of change. You almost took us kind of like finding the slope, I guess, if you want to call it that. So that is everything. So the regression model is usually a better predictor. It's a more accurate predictor. And that's why we do that. Use the regression model, because we get a more accurate picture. All right, let's look at number 4. The atmospheric pressure decreases with increasing altitude. At sea level, the average air pressure is 1 atmosphere, which is 1.033227 kilograms per square centimeter. The table shows the pressure P in atmospheres at selected altitude H in kilometers. Use a graphing calculator to find a logarithmic model of the form H equals A plus B ln P that represents the data. Estimate the altitude when the pressure is 0.75 atmosphere. All right. So what do we know about this problem? All right. First, we have to enter our data, just like we did in the example up above. So you're going to need to go back to your calculator and do stat. Oh, where did it do that to me? Stat. And you want to do number 1. Actually, let's not do number 1. I'm going to do number 4, which is clear list. So number 4, which is CLR LIST, clear list. That clears out your data. Then go back into stat number 1 and edit your list. This is X. This is Y. Okay, so when we're doing this, and it gives you your time to do your regression, once you get your data in, you want to do that, and you're going to arrow over to calculate, ALC. And then we want to do a logarithmic one. So when I go there, I'm looking for number 9, which is ln reg, natural log regression. Notice the formula is a natural log. A and B is what we're looking for. And when we do this, our little menu will pop up and we'll get ln reg, and we have the form y equals a plus b ln x, and a in this case is going to be 8, so 0.86, so 0.8626, and a couple more, and b is going to be negative 6.4473, blah, blah, blah. And since I'm rounding everything to the nearest hundredth in these equations, I'm going to have the equation y equals 0.86, or sorry, h equals, not y, because we're talking about h, 0.86 minus 6.45 ln of x. So estimate the altitude, which is the height, when the pressure is 0.75. That is the x value. So h is equal to 0.86 minus 6.45 times the natural log of 0.75. So you would just type that into the calculator, and you would get an answer of approximately 2.7. So when the air pressure is 0.75 atmosphere, the altitude is about 2.7 kilometers. So it's just a matter of taking your equation once you find the regression and substituting in an x value to help you find your answer. All right, that is it.